For centuries, humanity has believed one truth about the cosmos, that nothing in it ever truly stands still. Every planet spins, every star burns, and every comet races endlessly through the void. But a few months ago, that certainty shattered. The James Webb Space Telescope and observatories across the world detected something that should be impossible. TOI-Atlas, an interstellar traveler older than our Sun itself, suddenly stopped moving. Not slowed, not dimmed, stopped. It was as if the laws of motion, the very heartbeat of the universe, had skipped a beat. Instruments confirmed it wasn't an error. Multiple telescopes across continents and in orbit all saw the same impossible image, an object frozen in place against the backdrop of the stars for hours, maybe days. And when 3I Atlas finally began to move again, the questions it left behind would shake physics, astronomy, and even philosophy to their core. Was it a simple cosmic illusion, or proof that there are forces or technologies beyond anything we've ever known? Because this wasn't just another comet. The James Webb Telescope captured thermal oscillations, rhythmic shifts in temperature, and patterns of light that looked less like chaos and more like control. Something or someone seemed to be regulating this object. So what really happened when the universe went silent? What could make a massive interstellar body defy gravity, inertia, and time itself? As scientists are now discovering, this wasn't just a pause in motion. It was a message. It began like any other night of observation, quiet, routine, and predictable. Across observatories from Chile to Hawaii, astronomers were tracking the faint shimmer of 3I Atlas, an object known to be on a hyperbolic trajectory cutting through our solar system, a cosmic passerby never meant to return. But then the unthinkable happened. At first, the instruments showed a strange flattening in its velocity curve. The object's measurable motion across the sky, its proper motion, began to decline. Within hours, it reached zero. 3I Atlas, an interstellar body traveling at tens of thousands of kilometers per hour, stopped. The disbelief was instant. The laws of physics leave no room for rest in space. An object in motion must stay in motion, unless acted upon by a force. Yet no gravitational field, no visible jet, no nearby planet or magnetic influence could explain this event. It was as if the very fabric of space around it had conspired to hold it still. Technicians first suspected a calibration error. Perhaps the telescope's tracking software had glitched, or a background star had aligned perfectly to mask the movement. But within minutes, confirmation came from other observatories: Japan, Spain, Australia. Even amateur astronomers using high-sensitivity telescopes reported the same anomaly. 3I Atlas was motionless. That's when panic turned to awe. Nothing, not comets, not asteroids, not even spacecraft, had ever done this before. The idea of an object pausing in space contradicted everything Newton and Einstein ever taught us. A hyperbolic orbit means escape, momentum that never stops. But the trajectory data showed something else entirely. A sudden plateau in speed, a silence in motion, as if some unseen force had pressed pause on the universe itself. NASA and ESA teams rushed to rule out natural explanations. Could the sun's gravity have counteracted its velocity? Impossible. At that distance, solar pull was far too weak. Could it have been hit by another body? There was no debris, no shockwave, no shift in brightness. The phenomenon defied every model, a mystery wrapped in precision. For hours, the object remained fixed. Not drifting, not spinning off course, not accelerating. A frozen beacon in the dark. Even the background stars continued to move behind it, confirming it wasn't an illusion. It was the cosmos that moved, not 3I Atlas. And then, just as abruptly as it stopped, it began to move again, slowly at first, as if regaining consciousness, then smoothly returning to its original path, leaving behind nothing but data and disbelief. That moment, the day motion itself faltered, would become one of the greatest puzzles in astronomical history. Scientists now refer to it as the pause, but as new analysis from the James Webb Telescope revealed, what happened that night wasn't just a glitch in celestial mechanics. The readings taken during those hours, the thermal pulses, the subtle oscillations in light, hinted at something even stranger. Because during the stillness, 3I Atlas wasn't silent. It was active. When the data from the first observatory came in, disbelief was the natural reaction. A pause in motion, impossible. Every scientist on duty assumed a malfunction, an error in calibration, A glitch in software, maybe a momentary disturbance caused by solar radiation. But that illusion shattered when, one by one, observatories across the world confirmed the same impossible thing. From the Subaru telescope in Hawaii to La Silla in Chile, and even the European Southern Observatory in Paranal, astronomers began reporting identical readings. 3I Atlas wasn't moving. The stars in the background shifted as expected. The galaxies drifted as they always did, but the interstellar object at the center of every frame remained locked in place, perfectly stationary. Within hours, confirmation spread beyond professional networks. Amateur astronomers with high-precision instruments began capturing images that matched the professionals' data. Even small observatories in Spain, Japan, and Australia verified the same coordinates. The object's relative position against the background sky was unchanged. It wasn't an error of optics nor of perception. It was real. The news raced across the international astronomy community. Data synchronization between multiple instruments, optical, infrared, and radio, ruled out the possibility of a shared error. The phenomenon wasn't atmospheric. It wasn't software. The pause existed in space itself. The first official alert came from a collaboration between NASA's Minor Planet Center and the European Space Agency. Their joint message circulated among scientists with coded urgency. Object 3I Atlas currently displays no measurable motion relative to background stars. Multiple confirmations received. Cause unknown. That phrase, cause unknown, sent ripples through every lab and control room. Researchers combed through every conceivable explanation. Could the telescopes have aligned perfectly with 3I Atlas's vector of motion, creating the illusion of stillness? Simulations quickly disproved that theory. The object's velocity and the Earth's orbit made such alignment impossible. The Hubble Space Telescope soon joined the effort. Despite its lower infrared sensitivity compared to the James Webb, Hubble's long-range optical imaging provided independent verification, the same stillness, the same position. Its sensors, too, detected no parallax shift, no measurable drift. The object wasn't merely slowing down, it was truly static. Meanwhile, James Webb, orbiting far beyond the Moon, captured something deeper. Its infrared detectors recorded thermal variations, small but rhythmic, rippling across the object's surface. It was as though the body was alive with faint oscillations, breathing even as it remained motionless. By the time data from ground-based and orbital telescopes were cross-checked, one thing was undeniable. This wasn't a local anomaly. It was a cosmic event, visible across the entire planet, confirmed through multiple independent optical systems. In science, replication is everything, and replication was exactly what made this moment terrifying. Across every observatory, every telescope, and every mind staring into the night, the realization sank in. The laws of motion had just broken right in front of us. And as scientists rushed to explain the unexplainable, one question rose louder than the rest. What kind of force could silence motion itself? The answer, as they would soon discover, lay not in gravity or light, but in the unseen fields of energy surrounding the sun. When the stillness of 3I Atlas was first confirmed, physicists around the world reacted the same way, with disbelief. An interstellar object like this one moves along what's called a hyperbolic trajectory, a one-way path through a star system. By definition, it cannot stop. Nothing with such velocity and momentum can simply pause in the vacuum of space. The mathematics of orbital mechanics don't allow it. The universe itself doesn't allow it, yet here it was, motionless. According to every law we know, an object that crosses into the sun's gravitational field from interstellar space does so with enormous kinetic energy. The sun's pull can alter its path, bend it slightly or accelerate it, but it can never make it stop. To halt a body traveling at tens of kilometers per second would require a counteracting force equivalent to billions of nuclear detonations, a level of energy not found in nature outside of stellar explosions. And still 3I Atlas wasn't moving. The first explanation proposed was deceptively simple, a perspective illusion. Maybe the object was moving directly toward or away from Earth, making its motion appear invisible from our line of sight. But parallax data ruled that out immediately. Observations from different positions around the globe, and even from space-based telescopes, all showed the same thing: no relative motion. Then came the idea of optical error. Perhaps the object's brightness had fluctuated, giving the illusion of stillness. But spectral analysis destroyed that theory too. The light curve remained stable, with no interruptions or distortions to explain the apparent halt. That left one chilling conclusion: the pause was real.